Here we have a perfect competition problem. I'll leave you to read the narrative here. So we've got a market that is going to meet multiple requirements of the definition of a perfectly competitive market. We're going to create a market demand and supply graph based on the data on this sheet here. The demand curve for the data. So we're going to have quantity demanded on the X, and we're going to have price on the Y. So there's our demand. Now let's add supply. So supply curve, let's have quantity supplied. And we'll have the price. So now we've got demand and supply. And we've got the legend on there already. So let's add axis titles. Price and quantity. So we'll snap this in here. I'll check the format, should be 3 by 5. To get the equilibrium, clearly the intersection of demand and supply when lines cross, that's going to be important. If I hover over here, I see that this point is quantity of 2400 and price of 4. So we're going to use a cell reference here. We'll reference the price in the data sheet, and for the quantity we'll reference that in the data sheet also. For fixed cost, we want an absolute cell reference, and as you may recall from earlier, when the quantity is 0, whatever the total cost is, that would be our fixed cost, because there aren't any variable inputs there. Materials, labor, things like that. So we have an absolute cell reference that this fixed cost is 10 million. So for the variable cost, that is going to be the difference between the total cost and the fixed cost. So there's no difference when there's 0 output, but obviously this grows as we produce more. Average total cost will be the total cost divided by the quantity. So 2026. And as we produce more, we see that this average total cost falls, meets a minimum, reaches a minimum, and then rises again. The average fixed cost is fixed cost divided by quantity. So we're going to see that this falls rapidly at first and then tapers off. So cut in half, but then falling by smaller and smaller increments. Average variable cost will be variable cost divided by output, 26, and we'll see that this is rising. And then we've got the marginal cost. So for the marginal cost, we need the change in the total cost So the change in the total cost, that's going to be divided by change in the quantity. So this is going to give us the cost of one additional unit, in this case bushels. How much does one additional bushel cost when we're moving from none to 500? So in that range, the marginal cost is 26 cents. But as we'll see, spread this down, the more we produce, the more rapidly this rises. Next, we want a graph: average total cost, average fixed cost, variable cost, and marginal cost. So click in this area, insert, and we're going to look for scatter plot with straight lines again. It's going to be this one here. So again, need to go in. Now we can start adding average total cost, and X values are going to be the output. I'm going to start at 500 because we don't have any averages calculated when there's zero output, because you can't divide by zero. And then we'll grab this average total cost. So it's going to be our first piece. Then we're going to add average fixed cost. Over the same range. Average variable cost. Starting at 500 up to 10,000. Finally, marginal cost. So we'll snap this down here, go to format, 3x5, It's great. Okay, so I want a set of chart axis titles. Based on C, between which quantities is average total cost minimized? Assume, given the opportunity, the farm would want to produce more instead of less. So, part C, we're looking for where average total cost is minimized. So that's it. There's 451, 448, 451. So it's going to be in between these 4,500 and 5,000. So we have to do this from the lowest to the highest. So 4,500 to 5,000. So where would the firm aim to produce? So they're going to produce where the price, which we calculated here, $4, which is also the marginal revenue, is equal to the marginal cost. So the marginal cost passes between 376 and 426 here. So the farmer will produce between 4 and 4,500. So between 4 and 4,500. So using the law of the quantities, so we'll pick that out by using the minimum function, so that's 4,000. So the total revenue will be the 4,000 multiplied by the price of 4, which we have up here. So 16. So the total cost is going to be total cost of producing at 4,000, which is 18,020. And that gives us a loss of 2,020. In the short run, the farm will decide to grow corn. It will decide to grow corn because at this output, we are covering our average variable costs. So at this output, average variable costs are just a little over $2 here. And we're selling each bushel for $4. So that excess, that $4 minus the 201, is helping to pay down the fixed costs and shrink the loss. Were we to shut down, we would have to still pay those fixed costs and the loss would be far wider. So we decide to grow corn and make this smaller loss. In the long run, firms will leave the market. And as they do, the number of suppliers contract, the market equilibrium price will rise as the supply curve shifts leftward. And as that price rises, it rises for each of the individual firms. And then they can move back to what we call normal profit in the long run.